Hi, my name is Will, and I'll be talking about our paper, A Declarative Specification for Authoring Metrics Dashboards. Dashboards serve a variety of purposes, especially monitoring and breaking down metrics of interest. For example, in these two dashboards, we see different types of metrics dashboards. In the one on the left, we see a dashboard for tracking product complaints, where our metric here is the number of complaints broken down by different dimensions. In the dashboard on the right, we see a dashboard for tracking revenue metrics for a company. Yet authoring dashboards is still difficult. Popular interfaces like Tableau, Power BI, and Looker often focus on a bottom-up creation paradigm where they create charts first that are then composed into dashboards. However, these sort of authoring flows still require expertise to get the right data and many design decisions in actually creating dashboards. Recent approaches to dashboard authoring have sought new ways to actually create dashboards. For example, the Medley work focuses on a task-based authoring flow where users have to select a task like measure analysis or category analysis, and they suggest appropriate visualizations, where the multi-vision work focuses on a deep learning-based approach to creating exploratory dashboards where they recommend different charts and views of the data. However, our key insight is to leverage the repetitive structure inherent in many metrics dashboards. For example, that metrics dashboards are not just random collections of visualizations and tables, but have a structure of sections of metrics combined with different dimensions. For example, if we return to the complaints dashboard from earlier, we see that this dashboard tracks one key metric, the number of complaints, split across different dimensions, such as the month, reason, state, and party. And we can leverage this insight for the quick dashboarding specification and UI. And our goal with this is to help users bootstrap dashboard creation for metrics of interest split across dimensions without having to write data queries or manually create visualizations. Why quick dashboarding? This allows users to specify what data they need, and the system decides the rest, such as chart types, encoding mappings, etc., so they can focus on interesting combinations of data rather than how to actually write it out or create the charts manually. We do this with three key requirements. The first is to specify dashboards based on repeated metrics and dimensions. The next is that we allow customization afterwards, especially for things like a layout or if users want to customize the chart type. And the third is that we only provide a single dashboard per spec, so the users don't have to browse through different created dashboards. To create this, we use the quick dashboard specification. And although short, the specification is very rich and can create many different dashboards. And it does this by having sections of metrics and dimensions. Within each metric, we have quantitative fields and a list of quantitative fields. For each dimension, we have different categorical fields, where there are dimension groups of primary and secondary fields that break down these metrics. And we combine our metrics by either layering or repeating them. And I'll show some examples in a minute of what these different options produce in the resulting dashboard. We also created the Quick Dashboard UI as a prototype that leverages the specification. It allows users to create groups of metrics split by various dimensions. And within each of these groups, all metrics are compared to all dimensions. So, for example, if we use this input in the UI, we have 3 different metrics in 2 different dimensions. We'll combine all these to have 6 resulting charts that we see in this dashboard. To actually translate our spec to our dashboard, we take the cross product of all the specified metrics and dimensions per section. And when we layer our metrics, we combine these into one group for the cross product, so we layer all the metrics onto one chart. And I'll show what this looks like in some examples. So next I'll present some example quick dashboards. The first scenario is how we can break down different metrics with this paradigm. So in this case, we have 2 separate metrics, the sales and the shipping costs, in 2 different dimension groups. So in each we have a dimension, such as ship date and region, and we're repeating our metrics, so we're not going to put them on the same chart. In the quick dashboard UI, what this looks like is that we have 2 separate metrics specified in 2 different dimensions, and we see that since we have two metrics, 2 dimensions, we'll end up with 4 total charts in our preview. And the resulting dashboard also has this, where we can see at the top our first metric of sales, and at the bottom our second metric of shipping cost, and both are broken down by ship date and region. We can also do this for a single metric broken down by different dimensions. So in this case, we have a single metric of sales broken down by 4 different dimensions. The first is actually no dimensions, so we're just looking at sales in aggregate. Next, we're breaking down by sales across order date and market, and across market and category in this dashboard. Our next scenario is comparing metrics in the same chart. So in this case, we have a very similar specification to our first example. We have 2 separate metrics, sales and shipping costs, broken down by 2 different dimension groups. In our second dimension group, we've added a secondary field just to break it down even further by ship date and region. But in this case, we're going to layer our metrics so we can plot them on the same chart. So as we see in the quick dashboard UI and preview, what this actually means is that we'll only have 2 resulting charts since we have 2 metrics and 2 dimension groups, but we're layering both of these metrics on the same chart. So we have 2 resulting charts, and we see these charts in the resulting dashboard where we have both metrics on each chart. In the first, we're seeing the sum of sales and sum of shipping costs broken down by ship date, and the next, both of these metrics broken down by ship date and region. Lastly, we can combine these ideas to create rich dashboards out of multiple sections. So if we take our specifications from the first 2 scenarios, we can create a rich dashboard that has multiple sections. And we see this in the specification on the left, where we have the first example in section 1 and the latter example in section 2. And we can see this in the resulting dashboard as well, where we can have totally separate metrics, totally different dimensions in each section, and use this to create rich dashboards. This work shows how our specification can be used in future dashboard authoring tools, where we can think about dashboards as sections of metrics combined with dimensions. Next, this shows how we can focus on data more than specification through this sort of authoring paradigm. By bootstrapping the creation process, this makes exploration easier, so users can focus their attention on interesting relationships or combinations in their data, rather than how to write the queries or how to actually create the charts in the tool. Last, this shows how opportunities for further incorporating best practices can be used for dashboard creation. For example, in our tool right now, we're helping enforce axis consistency, where the same field is placed on a similar axis when it's repeated. However, future tools can also help enforce using the same color for different fields across sections, etc., through these sort of automated dashboard creation tools. This has been our paper, A Declarative Specification for Authoring Metrics Dashboards. Thank you so much.